Good morning. Good morning. This is Dr. P. Srinivaslu, presently working as Associate Professor in Ashankara College of Engineering Technology. In YouTube lecture series, the subject signal systems. Today topic is Fourier transform. We consider this Fourier transform signal is a rectangular pulse. This we know the rectangular pulse. The duration of rectangular pulse is from minus t to plus t. In this duration, the amplitude of that rectangular pulse is 1. So the Fourier transform of x of t is x of omega. You see this one, x of omega is equal to integral minus infinity plus infinity x of t into e power minus j omega t into dt. But the rectangular pulse is existing from minus t to plus 2. Within this duration, the x of t, the given signal x of t is a 1. So the limits were changing from minus infinity plus infinity to minus t to plus t. Within this duration, the amplitude of x of t is 1. So it is 1 and remaining e power minus j omega t into dt. We integrate this e power minus j omega t with respect to dt. It is like a e power minus at formula. So e power minus at by minus a. So here instead of a, we have minus j omega. So e power minus j omega t divided by minus j omega. Now you substitute these limits minus t to plus t. Now after substituting these limits, e power minus j omega t minus e power minus e power j omega t. To take minus is a common. It can be written as e power j omega t minus e power minus j omega t. Now 2 gets cancelled. No. E power, we have a standard formula. E power j omega t minus e power minus j omega t by 2j is a sin omega t. So the amplitude of that signal is now 2 by omega. Now we have a standard signal, a Sinc pulse. Now if you change this sin omega t into Sinc function, Sinc of theta is equal to sin pi theta by pi theta. So here this omega t is rearranged like sin pi theta by pi theta. So there is a pi, there is no pi in the original equation. So we multiply and divide with pi in sin of pi into omega t by pi in the numerator. In denominator also we can change like this. pi into omega t by pi. So now you can see this sin pi theta by pi theta like a sinc of theta. So finally 2t into sinc of omega t by pi. So this sinc function has a maximum value at sinc of 0, and the omega is goes on increases whether from 0 to positive frequency up to infinity, and 0 from 0 to negative frequency up to minus infinity. The it is goes on that corresponding amplitude goes on decreases. So, and it has a zero crossing points whenever there is a sin pi omega t by pi. So already pi is there. It is sine function, we know, zero crossing points, integer multiples of pi. So this omega t by pi is going to be like a integer. So this omega t by pi is equal to, if you like, integer multiples. So this is plus or minus 1 plus or minus 2 like that. Now omega is equal to pi by t plus or minus pi by t plus or minus 2 pi by t, like that we have a zero crossing points. Now finally, the rectangular signal, if you apply a time domain signal, is a rectangular pulse, and if you see in frequency domain, it is a sinc pulse. Now if you want to draw the magnitude spectrum and phase spectrum of a rectangular pulse, so the standard signal sinc signal already we know. You substitute different values of omega here, and anyway we have a zero crossing points at omega equal to plus or minus pi t pi by t plus or minus 2 pi by t plus or minus 2 pi by t. So in between 0 to plus or minus pi by 2, if we substitute different values of omega, and we are going to get the magnitude spectrum is like this. You observe it here. At omega equal to 0, this sinc function, sinc of 0 is 1. It is obtained from L hospital rule. So at sinc of 0, the amplitude is 2t, and at remaining frequencies, anyway we know at zero crossing points, we are going to get the zero crossing points at integer multiples of pi by t, 2 pi by t, and 3 pi by t plus or minus. So, and if you substitute, if you tabulate the readings for magnitude spectrum, omega versus magnitude of x of omega, and if you draw, the signal is a sinc signal. So it is the relation between rectangular pulse to sinc. Now, if you take inverse of this, inverse means, suppose the signal is a rectangular pulse in time domain. If you see in frequency domain, it is a sinc function. Now, I am changing this rectangular pulse in frequency domain. So, if you observe, previously time domain signal is a rectangular pulse, frequency domain is a sinc function. Now, I am considering the frequency domain is a rectangular pulse. So, definitely you will get a time domain signal is a sinc function. So, there is a vice versa Fourier transform pair in between. If you take a rectangular pulse as a time, frequency domain is sinc. If you take a rectangular pulse in frequency, time domain is a sinc. So now already the given signal is in frequency domain. So if you apply corresponding time domain signal, we need to calculate time domain signal. So inverse Fourier transform of x of omega is equal to x of t is equal to 1 divided by 2 pi integral minus infinity plus infinity x of omega into e power j omega t into d omega. It is a Fourier transform formula, inverse Fourier transform formula. Now here also the formula is from minus infinity to plus infinity. But this rectangular pulse is existing in frequency domain from minus omega to plus omega. So I am changing these limits from minus infinity to plus infinity to minus w to plus w. Within this duration, The rectangular pulse in frequency domain is a 1 and remaining e power j omega t into d omega. Again, if we integrate this one, integration of e power j omega t, we are doing integration with respect to d omega. So e power j omega t divided by jt. And if you substitute that limits minus w and plus w, again, we are going to get 1 by pi t into sine omega t. Again, you change this sine signal into sinc signal. So sinc of theta, already we know sine pi theta by pi theta, or sinc of lambda is equal to sine pi lambda by pi lambda. So 1 by pi t into sine omega t. So sine, it is not omega, sine wt. W is a constant here. So you can change like sinc function, you just multiply the numerator and denominator with pi. So it is like a form of sine pi theta by pi theta. Here theta is omega t by pi. So finally, you will get a sinc function. I've seen, observe this one, omega by pi into sinc of omega t by pi. So already sinc means sine pi. So it has a zero crossing points. Omega t by pi is equal to plus or minus 1, plus or minus 2, plus or minus 3. So t is equal to pi divided by w. So plus or minus pi by w, plus or minus 2 pi by w. We are going to get zero crossing points. As usual, yet it is a maximum at time t equal to 0. Time t equal to 0, the amplitude is w by pi. And remaining whenever time is increases from 0 to positive infinity and from 0 to negative infinity, that corresponding amplitudes are goes on decreases. Again, it is a symmetry. The sinc function satisfies even symmetry.